Okay. So I assume that everybody's here. Hi, everybody. My name is Edgar Holleis, and I'll talk about 3 strategies. And I think I'll just stop for a second because my Microsoft, I have some interference here. Okay. And I'll try again. My name is Edgar Holleis, and I'll talk about 3 strategies to secure the legacy beast. I insist that it's really a friendly beast. You can see it's grinning. This is legacy software. It has been running probably for years, and it's brought lots of value for your company. And it's really something that you might want to hold on to in the future. And sometimes this legacy software needs a little bit of a makeover, perhaps to meet new requirements, especially in terms of security. And this is what I'm going to talk about today. My name is Edgar Holleis. I come from an electrical engineering background. I made a PhD at the Vienna University of Technology, originally about wireless networks and security in wireless networks, and then moved on to Zühlke, where I have been an embedded engineer for the past couple of years, and now moved on to the security office. Just 2 slides about my company. We're Zühlke Engineering, founded 50 years ago. We are mostly centered in the Switzerland, Germany, and Austria region, but we have recently also looked eastwards. We've opened offices in Serbia and Bulgaria, and also in Asia. And hopefully, in a couple of years, Ukraine will also be part of our map, which is not at the moment. We are over 1,000 employees, actually 1,200, and of which 1,000 are engineers. Just 2 words about our offering. This is the offering we have in Austria. In Austria, we do mainly embedded solutions, focusing on industry customers. We do IoT and data analytics, what we have been doing for quite a while now, maybe even before the term IoT was coined. We do software modernization, which is also the topic of today's talk. In software modernization, we don't only have industry customers, but also customers from banking, from insurances, and other industry, government, for example. And we do experience innovation. Experience innovation is about creating new interfaces, new ways to interact with software and with systems, about usability. It's about usability. As you can see in the picture above, we do that, for example, with HoloLens. What really sets us apart as a company is that we are look for customer value. We are successful through the success of our customers, and we are an innovation company. Innovation for us means the whole cycle from ideation, from business analysis over to requirements engineering, to implementation, and to the later phases like maintenance. And we also have operations people in Serbia. Today, we're going to talk about software. I'm going to talk about software modernization. Here's the friendly beast again. From now on, we will call it systems, because it's essentially that. I'm going to talk about 3 situations, 3 systems, and 3 different customers, and 3 different strategies, how we dealt with that. So on to the first example. This is really the smallest of the 3 examples I'm going to bring. It's a customer portal. It's dealing with intelligent devices, and it's there for customers to manage their own devices. It's to manage maintenance using subcontractors and to order consumables. And we have so here are the devices, we have various interfaces, and we have links to other systems like customer relationship manager and enterprise resource planning. And this system developed several security problems over time. The biggest was probably the commissioning procedures of devices was too complicated. I wouldn't say that it was insecure. It was simply too complicated. You needed really specialists in the field to bring these devices online and connect them to the backend, and that made the architecture unfit for new requirements. And in this case, we did something pretty classic, which I call replace and contain. So we went in and we built a new system around the old system, and we gradually migrated features from the legacy system to the new system, and we kept the legacy world running to care for the legacy devices, and the new generation of devices was directly connected to the new system. So after our work, it's now a cloud-native application, which it was not before. Before it was already running in the cloud, but it was basically running as several virtual machines. Now it's really a cloud-native application, and we are also using it's hosted in the Azure cloud, and it's using the components that exist there to its profit. And the thing to take away from that is that security drives architecture. That means that's a classical thing that they always say that you have to think about security early in the project rather than late. I cannot agree more with that. But I also have to say that, of course, you can do security late in the project. Of course, that's not good for schedules and budget. And you will probably have to touch the architecture again. So if you want to change the security, you often have to change the architecture. And if you cannot change the architecture, your best option is to replace large parts of the system, just as we did in that example. On to the next example. This is another example from industry. This is probably because I'm come from embedded systems. It's a vast digital services hub, many times larger than the system we've seen before. It's again about devices and consumable, and it has grown organically, mostly through merger and acquisitions. And some parts of the system are over 30 years old. It also has had various security problems. The easiest of that is maybe that it had the identity server it was using was simply discontinued by the vendor. It had several instances of what I call what is commonly called the inner platform effect. That is basically, for example, and to bring an example, that's a database, and on top of that there is a key value store, and on top of the key value store, the engineers build another database. That sometimes happen if you let loose inexperienced engineers with unclear requirements. Then the system had no or outdated encryption. But perhaps the biggest problem was that for the most part of the lifetime of the system, it was always playing catch up with business needs. So the business was also always moving faster, a new merger, a new acquisition, new features. There was never enough time to do things right and to care about security. And in that situation, we did something pretty drastic. I call that the strategy move fast and break things. That's a term coined originally by Mark Zuckerberg, the founder of Facebook. What we did is we went in and consolidated a lot of the internal databases. There was far too many databases in there, and we consolidated the major functions and really made a clean new system, built it. We aggressively retired legacy interfaces that were not used anymore. We consolidated it, we built the systems, and we tested it to the amount that we could. We deployed it, and the final test was actually done in production, but we always had a plan how to roll back changes if something major breaks. And throughout the project, we had to do that twice, where we deployed something that impacted some parts of the business in a major way. We rolled it back, we fixed it, and we tried it again. So of course we put in a new and now a unified identity server. So users and devices in the systems now got their own unique identity, and we greatly improved web security. And the takeaway of that is that it's crucial to align business needs and security needs. In the case I was showing, it was always the business needs first and the security was lagging behind, or not only security, but security and architecture was lagging behind. But it would be also very detrimental to have it the other way around. I have seen far too many organizations where even if there is a clear business case that system A should talk to system B, the security guys would have none of it, and they would give excuses like this is against firewall policy and network zones and whatnot. My thinking is if there is a clear business case and the business case can pay for it, then we should go in and we should fix the system and make the security and the business side work. So here comes the third example. This is an example from government. It's a vast data acquisition network. It has strict security requirements. And I have to say that it's in fact well architectured. So a lot of good thinking went into the design. The problem with the system was more in the details. As you can see here, broken tools, functions. They were even running their own PKI infrastructure, which is typically a sign of very advanced security features. But things were broken in various ways. The biggest problem was perhaps that it was complicated and hard to use. And there were many security alerts for non-security reasons. And all that resulted in very poor operational security because the people doing operations, they basically had to create their own workarounds all the time to work around the problems that the system presented. They were keeping remote interfaces open. Of course, those remote interfaces or remote access interfaces that were poorly secured, and there was default passwords all over the place. So this is a case where a good system with a few problems turns out to have poor operational security in the end. And what we did was a gradual change from within, as I would call it. We went in and we fixed issues. We improved the user experience. We reworked the tooling. We modernized the UIs, and we improved the robustness of various system components. We also did other work. We updated the cryptography, and we did a few small architectural changes. And those, of course, came with extensive planning, with simulation and testing. And we were really sure that this is going to work before we put it into production. And the takeaway of this is that security with bad usability results in bad security. And yeah, I have actually only two pieces of advice. You have to make the security components as robust as humanly possible. A security system should never fail for any lesser reason than an ongoing attack. And everybody hates security system that produces lots of false positives, like I'm thinking about expired SSL certificates and the sort. And the second piece of advice is you shouldn't expose the details of the system architecture to users who cannot understand it. You have to use metaphors, you have to stick to them, you have to give users guidance, don't expose them to things like certificate revocation lists or certificate signing requests, those internal details that security systems tend to have. Okay, this is already it. To wrap up the talk, I've showed you 3 different systems with 3 sets of security problems and 3 different strategies that we used, how to cope with that. And if any of that sounds vaguely familiar to you, then maybe we should talk and make business arrangements. I will, so you can see my email address here. You can see the webpage of my company, and I'll linger some more in the place outside of the lecture hall. And with this, I'm already open to questions.
Эдгар, благодарим вас. Сейчас мы подождем вопросы, если такие будут. А пока мы ждем вопросы, я запущу опрос. Мы видим, что вопросов нет. Эдгар, большое вам спасибо за презентацию. Встретимся на платформе.